So today we are going to look at lesson 6-4, and we're just really looking at expressions. We're not going to be concerned with an equal sign or anything like that. So a rational expression is just a quotient of two polynomials, something divided by something. So some examples might be x over x squared, or you could have 2x minus 4 over x minus 2, or there's something a little bit more complicated, x squared plus 3x plus 2, all divided by x plus 3. So all of these are considered rational expressions. Then the simplest form just means that you need to reduce it down to, you got to factor it and reduce it down. So if you started off with x squared minus 7x plus 12, plus 12, all divided by x squared minus 9. The numerator could be factored as x minus 4. Let's try that again. Yeah, x minus 4. And then x minus 3. All divided by x plus 3, x minus 3. And so as we've discussed before, the x minus 3's could cancel, and you're left with this as your answer. So your answer would be x minus 4, all divided by x plus 3. So that's considered in simplest form. All common factors have been divided out. Then once we take an expression, factor it, cancel out any factors that are uncommon, and we get a resulting expression. For this expression and this expression to be equivalent, for them to be equivalent expressions, they need to have the same domain. So they have to have the same restrictions, in other words. So if I try to do restrictions looking at this original expression versus this one, there'd be two different ones. For instance, x cannot equal -3 here or +3 here. But if we're only looking at this expression, x would not be able to be +3 here only. So we had to come up with a plan as to which is it. Is it this original or is it our resulting equation? So we will always look at restrictions based upon the original fully factored expression. So if you look at this one right here, I'm going to get an equivalent expression to this by factoring. So the numerator will factor as x minus 3, x plus 2. The denominator will factor as x plus 2 and x minus 1. And so then the x plus 2's will cancel, and you will be left with an equivalent expression of x minus 3, x minus 1. But we have to come up with values that x cannot be, because we cannot have this denominator equal to 0. So you need to look at the fully factored original denominator right here before anything was canceled out. If I set this equal to 0, x will not be -2, because if x is -2, -2 plus 2 is 0. It will create a 0 here in the denominator. And then here, x cannot be 1, because if you put 1 in here, 1 minus 1 is 0, and that will create a 0 in the denominator. So we have to add what are called restrictions. X cannot equal -2 or +1. All of this will become our answer. We used to, prior to today, we used to look at this as, this is your vertical asymptote, x is equal to 1. This is being removed, so it's a removable discontinuity, so that's a hole at x is equal to -2, and you'd have to plug it into this expression to find the y value of that hole. This is different because we're just simplifying an expression, we're not graphing it, and we're just looking to see what are the restrictions on the denominator. So this is how those restrictions will be written. So let's look at several types of examples. So we're going to start pretty simple, and work our way to more complex situations. So I have a monomial divided by a monomial. No addition or subtraction signs are in sight. So I'm going to start with my numbers first, and so I'm going to look to see what 28 and -7 have in common. Well, they can both be divided by -7. So -7 goes in here once, -7 goes in here -4 times, so I'm left with a -4 in the numerator. Then for the variables, I typically go alphabetically. So these x's will cancel with 2 upstairs, so I'm left with an x up top. And then for my y's, these y's will cancel with 2 downstairs, so I'm left with a y in the denominator. So this is my fully simplified. I'm going to get rid of that. This is my fully simplified expression. This expression is equal to this expression. Of course, you have to look for restrictions, and anytime you have a monomial, 100% of the time when there are no addition or subtraction signs here, whatever variables you see here in the monomial, it's always x and y cannot equal 0. So x cannot equal 0, y cannot equal 0. Always, 100% of the time. All right, so let's look at b. So for b, you can factor the numerator, and at this point I'm making an assumption that you know how to factor. So you can factor the numerator as x plus 4, x minus 2. And your denominator would be x minus 2, x minus 3. And in this case, the x minus 2's cancel, so it's a removable discontinuity, and you're left with an equivalent expression of x plus 4 divided by x minus 3. But we have some restrictions where x cannot equal, and so for this one, even though it was removed, you have to look at the original fully factored denominator. So even though this was removed, if you set it equal to 0, x cannot be 2, and then this one, of course, 3. So x cannot equal 2 or 3. So C has a little bit of a quirk to it. If you just factor out a 4 here, then you're going to have 3 minus x. And on this one, the x comes first. So my suggestion would be that you factor out a -4. So if you factor a -4 out, you're going to get a -3 plus x. And then I could rewrite this as being x minus 3, which is what I'm going to do. So that got replaced with that, and so we end up with a -4 times, and I'm going to write it as x minus 3 instead of -3 plus x, over, then we have the difference of 2 squares, and I can cancel out an x minus 3 with an x minus 3, and so I get -4 in the numerator and an x plus 3 in the denominator. And x cannot equal -3 and +3. So plus or minus 3. All right, so then let's look at the next set. So for this set, they start to get a little bit more complicated, and or multiplying now. So we have multiplication and then division. That really doesn't change anything that we're doing. It just means we have more things that we're having to factor. So with A, which is quite crooked, it's a little bit better. So with A, you can cancel any one item with any one item in the denominator. So I can cancel all the way over here. I don't just have to cancel vertically. I can cancel all the way over here. So again, I like to start with my numbers first. And so 3 goes into 3 once, 3 goes into 12 4 times, and then the 5 and the 7 cannot cancel with anything, and so you're left with 1 times 7 is 7, and 5 times 4 is 20. Then we're going to go, I typically will go alphabetically. So I can cancel these x's with 2 down here, so I'm left with 1 x in the denominator. And then my y's cancel 1 for 1. And so all I have to add now are my restrictions. And then if you look at your original denominators, I've got a y and an x. This is a monomial, this is a monomial. Remember, anytime you have a monomial, whatever variables are down there cannot equal 0. So in this case, x cannot equal 0, and there's a y. Even though it canceled out, the y cannot equal 0. So this is your solution. Let's look at b. So for b, I can factor the first numerator as 3 times x minus 2. And I would just suggest you pause the video at this point and see how you're doing. Can you factor? Can you cancel all the factors that you possibly could? And can you find the restrictions? And then restart the video. This denominator is x plus 2, x minus 2, times this numerator is x plus 2, x plus 3, and the last denominator is x plus 3, x minus 1. And so the x plus 2's are going to cancel. The x minus 2's are going to cancel. And the x plus 3's are going to cancel. And that leaves me with a 3 up top and an x minus 1 in the denominator. But I still have restrictions. Now you've got 4 factors here, and they're all different in the original multiplication before we ever canceled. And so you've got to look at all of these and use them all for your restrictions. So x cannot equal negative 2, or positive 2, or negative 3, or positive 1. So x cannot equal positive or negative 2, negative 3, or positive 1. So I have 4 restrictions on that one. If you were asked to write the domain for this, again, you would start from small to high, and so your smallest number is negative 3, then negative 2, and then 1 and 2. Each time you reached one of these restrictions, you'd have to make a break in your domain. So for instance, your domain would start at negative infinity till you come to the smallest of these 4, which is negative 3. At negative 3, there is not an x value there because it's undefined. So you would have to either leap over a hole or jump over an asymptote wall. And so you're going to union that. You'd have to be on the other side of the hole or the wall. And then you would go to your next number. So the next number from negative 3 is a negative 2. So you'd go to negative 2. You'd have to leap over something, so there's a cut. You get on the other side of that something, and you get a negative 2. So then from negative 2, our next smaller number is positive 1. So we'd hit positive 1, union, and I'm going to move this over a smidge. I'm going to move this over a smidge. So then I would start at 1 and go to 2. So that's my last one. And I'd have to jump over whatever there is at 2, union 2 to positive infinity. Goodness, I almost ran out of room. So here's my 1, 2, 3, 4 restrictions. And it actually creates 1, 2, 3, 4, 5 intervals. But that's it. They didn't ask for that, but if they did, that's what it looked like. All right, on to example 3. So with example 3, we are now dividing. So with division, you may have had teachers tell you in the past that you are going to keep, change, flip. Some people don't like that, but most of you tend to remember it. So keep means you're going to keep the first fraction exactly as you see it, don't touch it. Change means you're going to change division to multiplication. And flip means you're going to change this into its reciprocal. So the 8y goes up top, the 21x cubed goes in the bottom. So that's what we're going to do. We're going to keep, so I have 7x over 4y to the third. Then instead of division, we're going to change that to multiplication, and then we're going to flip this fraction. So the 8y is going to go up top, and the 21x cubed is on the bottom. And then you just treat it like we did above, like a multiplication problem. So I'm going to start with my numbers, and 7 and 21 have a common divisor. 7 goes into 7 once, and into 21 3 times. And 4 and 8 have a common divisor. 4 goes into 4 once, and into 8 twice. And then you're just going to multiply across. 1 times 2 is 2. And then 1 times 3 is 3. So we have 2 over 3. Then alphabetically, I'm going to start with my x's. So this x is going to cancel with 1 downstairs, and so we're left with an x squared. And then for my y's, this y is going to cancel with 1 downstairs, so I have y squared. So this is the simplified expression, but I still have to look at restrictions. So when you look at restrictions, just like with multiplication, however, we cannot look at restrictions here because of the keep, change, flip. You always want to look at your restrictions in the multiplication problem that you change the division problem into. So we're going to look here for restrictions. Since I have monomials and I have an x and y in the denominator, x and y, x cannot equal 0, and y cannot equal 0. And so this would be your full answer. So then for B, we're going to do keep, change, flip again. So we're going to keep, and if you want to factor as your keep, change, flip, that's fine. I'm going to do an extra step. So x squared plus 5x plus 4 over x squared plus x minus 12. So that's my keep. I'm going to change this to multiplication, and then I'm flipping that whole fraction. So the 2x squared goes up top minus the 6x, and then the x squared minus 1 goes in the bottom. So then I am going to factor next. So this first numerator right here factors as x plus 1, x plus 4. This denominator here is going to factor as x plus 4, x minus 3, then times. This numerator here has the greatest common factor of 2x, so 2x is coming out in front, and then I'm going to divide each of these by 2x. So 2x squared divided by 2x gives us an x. And then 6x, negative 6x divided by 2x is a negative 3. All divided by, and then the last denominator is the difference of 2 squares. So x plus 2, or x plus 1, x minus 1. I can't even talk. All right, so now you're ready to start canceling. Now you could actually do restrictions now before you ever cancel, because it doesn't matter whether I cancel or not. So you just look at this original fully factored denominator. So here x cannot be negative 4, positive 3, negative 1, or positive 1. But let's go ahead and cancel. So x plus 4 cancels with an x plus 4. X minus 3 cancels with an x minus 3. And then x plus 1 cancels with an x plus 1. And I'm left with a 2x up top over in x minus 1. And then x cannot equal negative 4, positive 3, or positive or negative 1. Remember how we got those. So we got these by looking here. Setting that equal to 0, x cannot be negative 4. Setting this equal to 0, x cannot be 3. Setting this equal to 0, x cannot be negative 1, and x cannot be positive 1. So that's how we got all of those. All right, so I think that's all that we have on this page. Yep, so let's go look at the next page. So we are not going to do example 4. It's not my favorite example. So we're going to look at And actually what I want you to do, you're going to multiply or divide, it depends on what the problem's telling you to do. But at this point I want you to pause the lesson video. I'm trying to straighten this out. There we go. So pause the lesson video and I want you to complete A and B and then grade your answers. Okay, so for A, the first numerator factors as x plus 5, x minus 2. Then its denominator factors as x plus 6, x minus 2. Then times, there's no keep, change, flip here because it's already multiplication. The numerator of the second fraction has a 3 as a GCF, so you get x plus 6 over, and then the denominator does not factor, so I'm just putting it in parentheses. So then the x minus 2's cancel, the x plus 6's cancel, and that looks like that's about it. So you have in the numerator a 3 and an x plus 5. I don't typically multiply those back out. And in the denominator an x plus 3. And then x cannot equal. So look at your fully factored original denominators. Here x cannot be negative 6, x cannot be 2, x cannot be negative 3. So x cannot equal negative 6, 2, or negative 3. All right, let's look at B. So for B, the first fraction factors as x minus 2, x minus 5. Its denominator factors as x minus 3, x minus 5. Then because it's division, we're going to change that to multiplication, and then we're going to flip this. Well, I've already started factoring, so I'm going to factor as I flip. So this becomes my numerator, so I'm going to put it here. So I'm going to start here at the bottom. So this one is x plus 6 and x minus 3. Then this right here becomes my denominator here, but notice how it's x squared is second. So we learned this little trick before that if I factor out a negative, I will get a negative 4 plus an x squared instead of that. So then down here, this is going to end up being x squared minus 4. So x squared minus 4 is the difference of two squares. So I've got a negative, and then x plus 2, x minus 2. Why? Well, again, this right here factors as, you get negative x squared minus 4, right? And so the negative here is here. X squared minus 4 factors into, oh gosh, that shouldn't be a 4. That should be, oop, again, I'm having issues, clearly. Well, now I can't get rid of the 4. So instead, we're just going to make it a 2. That's a 2. Okay. Clearly I got distracted. So x squared minus 4 becomes x plus 2x minus 2. Now I can go and cancel. And again, don't forget, this is where that you are going to get, and don't forget about that negative, this is where you're going to get your restrictions from. So what cancels? X minus 5, x minus 5. X minus 3 and an x minus 3. X minus 2 and all the way over here an x minus 2. So that leaves me with, up top, in x plus 6, and in the denominator a negative times x plus 2. Now you could take this negative and you can push it to the numerator, or you can hang it out here to the side, it doesn't matter. You could also distribute it, or you can just leave it where it's at. So then our restrictions, x cannot equal, positive 3 here, positive 5 here, negative 2, and positive 2. So positive 3, positive 5, and then positive and negative 2. All right, so let's move on to our very last page and look at example 6. Okay, so when you're looking at a fraction, this is a complex fraction. You got a fraction inside of a fraction. So it's just this divided by this. It's still keep, change, flip. So you're still going to do keep, change, and flip. So we're going to keep this first fraction exactly as you see it. So I keep it as 8x squared y, all divided by x plus 1. And then I'm going to change this division bar into a multiplication sign. And then this is going to get flipped. So I get x plus 1, all divided by 6xy squared. So my x plus 1's can cancel. And then my 8 and my 6, they're part of the monomials. They have a 2 in common. So 6 divided by 2 is 3. 8 divided by 2 is 4. So I know I have a 4 up top and a 3 in the bottom. And then let's go alphabetically. So my x's, this x can cancel with 1 upstairs, so I'm left with an x upstairs. And then my y's, this y can cancel with 1 y downstairs, so I'm left with 1 y downstairs. And then restrictions. So look at your original fully factored denominator here. So here x cannot be -1. But here this is a monomial, so remember any variable that's in a monomial cannot be 0. So x cannot equal -1 or 0, and then also y cannot equal 0. So there's all your restrictions and your simplified fraction. So I would like you to do B. It looks difficult, but it's really not. So keep, change, flip, and then factor, cancel, write your simplified fraction and restrictions. Pause the video. Go ahead, pause it. Okay, so hopefully you actually pause the video. So I am going to keep, change, and flip. So I'm going to keep x squared minus 1 over x squared minus 9. I'm going to change division to multiplication, and then I'm flipping this fraction here. So I get x squared plus 8x plus 15 up top, and x squared plus 3x minus 4 on the bottom. So for the first fraction, the numerator factors as x plus 1, x minus 1. The difference of 2 squares. The denominator of that same fraction is also the difference of 2 squares, so that factors as x plus 3, x minus 3. And then times, the numerator of the second fraction factors as x plus 3 and x plus 5. And then the denominator factors as x plus 4, x minus 1. So now you can cancel, and I can cancel an x minus 1 with an x minus 1. I can cancel an x plus 3 with an x plus 3. And that appears to be it. So I have left in the numerator in x plus 1 and an x plus 5. Don't remultiply these. In the denominator, I have an x minus 3 and an x plus 4. So restrictions. X cannot equal. So here x cannot be -3 or +3. Here x cannot equal -4 or +1. So positive and -3, -4, and +1. And that's it. Text me with any questions. Good luck.